Okay, first problem asks you to find the average speed of a ball that rolls 20 domino lengths from rest in 5 cycles of a certain pendulum. Now, I used velocity rather than speed because speed is velocity without regard to direction. Okay, since everything is moving here in the same direction, all motion is in the same direction, we can call this velocity just as well as we could call it speed. So I'll use the term velocity. Since there's no motion in the opposite direction, we don't have to worry about this distinction between speed and velocity. So average velocity, okay, is what? Now, you could calculate this intuitively. You probably know to divide the 20 domino lengths by the 5 seconds. You're going to get 4 domino lengths per, not per second, per cycle. Okay, so, but at this stage, you want to use this rate of change definition. Okay, so I haven't written out all the details. I've just written the average velocity equals rate of change of ... etc. This means you should be going through in your head, okay, average velocity is rate of change of position with respect to clock time, which is change in position divided by change in clock time. You should recite the rate of change definition of average velocity before you go to change in position over change in clock time, or delta S over delta T. It's not a formula, it's an idea, it's a phrase, and you need to understand the phrase to understand completely what this is telling you, okay? That's very important. Okay, so in any case, our change in position, or our delta S, is 20 deciliters, 20 domino lengths, divided by the change in clock time, which is 5 cycles. And that gives us 4 domino lengths per cycle. Then you're asked for the final velocity. How do you get the final velocity? Well, initial velocity was 0, and implicitly the velocity versus time graph is assumed to be straight, a straight line. Okay, not sure this is completely legible, but initial velocity 0 and v versus t being a straight line implies that vf, that's a pretty bad looking f, equals twice v bar. The final velocity is double the average velocity. So the average velocity being 4 domino lengths per cycle, the final velocity is 8 domino lengths per cycle. In this case then, delta v, which stands for a change in velocity, is 8 domino lengths per cycle minus 0 domino lengths per cycle, or 8 domino lengths per cycle. Now, why would we be calculating that? I probably should have said it before. You're asked for the average rate of change of velocity with respect to clock time. Okay? And now that, again, equals ... rate of change definition. The rate of change of velocity with respect to clock time is change in velocity divided by change in clock time. And that's delta V over delta T if we do it in symbols. And in any case, delta V is what we just found, the change in velocity, 8 domino lengths per cycle minus 0 domino lengths per cycle. And obviously, it's not really necessary to write down minus 0 domino lengths per cycle. It is just 8 domino lengths per cycle, but you want to write it down this way to emphasize that this is the change in velocity and this is the final velocity. They might be equal, they aren't always equal. You want to make sure you understand that you have to subtract the initial from the final to get the change. And this reinforces it even if it isn't really strictly necessary. Okay, so anyhow, you got the change, 8 domino lengths per cycle divided by 5 cycles. And they divide that out, you get 1.6 domino lengths per cycle multiplied by reciprocal cycles. Now, in the preceding video, we talked about that calculation, how dividing by cycles here is the same as multiplying by reciprocal cycles. And that gives 1.6 domino lengths per cycle squared. Okay, this is a unit of rate of change of velocity with respect to clock time, not a unit of velocity. It shouldn't have the same units, and it doesn't. Now, this can be understood as 1.6 domino lengths per cycle per cycle. What's that mean? That means with every cycle, the velocity changes by 1.6 domino lengths per cycle. So there are a lot of per cycles in there, but if you think about it, they all make sense. And you want to think about it until they do. And if they never do, ask me. I'll throw up a video here to further clarify it for you. But be sure to give it some thought first, because it's better if you figure it out yourself. Okay. Yeah, I'm going to stop there. We'll go on to the next problem in a separate video.